Hey guys, welcome back. Happy Monday. So today we're going to review right triangles and then cross multiplying. And we're actually going to use Pythagorean theorem, something that maybe you haven't used since like middle school. So again, hopefully this is a nice little refresher. We will be using these skills throughout this first unit coming back here. Um, what are right triangles again? A triangle with an angle that measures 90 degrees. And again, we normally see that with that nice little box corner. That lets us know that, hey, that corner, that's the one that measures 90 degrees. That's that perfect sweet corner that we like to see. Now, a couple of other things, guys. Whenever you're dealing with a right triangle, we have something called the hypotenuse. The hypotenuse is always directly across that 90 degrees. So if you find that 90 degrees, walk directly across. That's the side that we're going to call the hypotenuse. Now, a couple of things. The hypotenuse, it is the longest side. It is the longest side, the longest side, the longest side. So kind of keep that in mind when we're moving forward. Now, over here, you'll see that the other two sides, we normally call them legs. It's the other two legs of the right triangle. And you'll see these letters A, B, and C, and I'll talk a little bit more about them in the next slide here. So we have something called the Pythagorean Theorem. It's a relationship comparing the three sides of a right. And again, it has to be a right triangle, and it goes a squared plus b squared equals c squared. I hope you've seen this before. Again, like I said, it's probably been a while, so it's all right if we forgot, but hopefully we've seen it here or there. Now, again, going back to why A, B, and C, and why did I put so much emphasis on C? Well, remember, if you have a right triangle, find that perfect corner, and if you go directly across from that, we told you that, hey, that is always going to be the longest side, and that's what we call your hypotenuse. Okay, so again, this is the longest side across that 90 degrees. We call that hypotenuse, and we typically label that with the letter C. The other two legs, I really don't care which one's A or which one's B. You can, if you don't like this one being A, you can call that one B if you would like. But again, the important part here that I'm trying to point out is that the hypotenuse, the letter C, that is always going to be the longest side. So when you write your equation a squared plus b squared equals c squared, be careful that c squared, that needs to represent the hypotenuse always, and that's kind of one of the popular mistakes that happens. And again, the other two legs, you can swap them, call one A, call one B, whatever you'd like. All right, a little bit about rounding here before because we are going to have to use this in a second. Rounding. Remember, guys, when it comes to rounding, if it is 5 or more, we're going to let it soar. We're going to round up to the next value. If it's 4 or less, we're just going to go ahead and let it rest. We don't round. I hate using the word round down because it does get confusing. You're just going to go ahead and leave it. You're going to let it rest as it is. You're not going to change that number. We're basically just going to truncate it. So here, it says round to the nearest tenth. Now, be careful. Take a look at these examples. Tenth, that is the first place after the decimal. Then we have hundredths. Then we have thousandths. So that's the third place. So if we're trying to round to the nearest tenth, so here's the tenth spot. What we have to do is we look to the right of it, and I see that it's the number 5. Well, if it's 5 or more, we're going to let it soar. That means that that 2 is going to get rounded up into a 3. So this is now going to be 314.3. All right. So we round that up to a 3. Everything else we get rid of. All right, let's try that one more time. Round to the nearest tenth for the next one. So here's the tenths place. It's the one space after the decimal. Now, if I take a look to the right of that, that's a 2. Well, that's 4 or less. So we're going to go ahead and let that rest. Now, again, I don't turn that 4 into a 3. I just leave it as 12.4. I just let it rest. Let it be. Leave it as 12.4. One last time. This is kind of when you have like one of those chain reactions. So take a look. If I round to the nearest tenths, if I take a look at it to the right, that is a 9. That is going to tell me that, well, that's 5 or more, so we do have to round up. But how the heck am I going to round up this 9? Well, this 9 gets kicked up to a 10. We kick over, right? Imagine this getting turned into a 10. We kick over that extra 1 there. So now what's that 7 plus 1 more? That is going to give us 18. This is going to be 18.0. All right. Let's move forward here. All right, so example 1, find the length of the missing angle. So this is where we're going to use the Pythagorean theorem. Let me write that a squared plus b squared equals c squared up above. And again, I want to remind you guys that it's always important to label your triangle. So what I'm going to do right here before I start plugging in and using that Pythagorean theorem to find my missing side, I do want to find this missing side here. What I'm going to do is I'm going to label A, B, and C on my triangle. First thing that I always like to label is the hypotenuse, the longest side, the letter C. So I find that perfect corner. I walk directly across and I hit that other wall. that is going to be my hypotenuse. That is the longest side, and I'm going to label that with the letter C. That is going to be my unknown. That's the one I'm trying to find. 15 feet, 20 feet, I don't care which one you call A. I don't care which one you call B. 15, I'll call it A. 20, we'll call it B. And what we're going to do is we're going to plug into our Pythagorean theorem here, do a little bit of algebra, and we're going to find that C, that missing side length over there. So let me write it one more time. A squared plus B squared equals C squared. Well, if I plug in everything that I know, it's going to look like this. A squared instead of A, it's going to say 15 to the second power. That's not 15 times 2. That's 15 times 15. We'll do that in a minute. Plus B squared. Well, what's B squared? That's 20 to the second power equals C squared. And actually, I don't know what that is, and that's okay. So we're going to leave it as C to the second power. That's a variable. That is our unknown. That is what we are trying to find. Think of it like your x. If you don't like the letter C, feel free to change it to an x right now. So let's do 15 to the second power. Let's go through and work this out. 15 times 15 is going to give me 200. Let me change colors. Give me a second. 225 plus, what is 20 times 20? That is going to be 400, and that's equal to C squared. All right, all I did was I worked out 15 squared, I worked out 20 squared. All right, now what we can do now is we can go ahead and combine our like terms. What's 225 plus 400? That's going to give me 625 is equal to C squared. Now, this is the awkward part. A lot of students think that they're done. No, we're not done. We don't have C all by itself. We still have that exponent, that power of 2 here that I need to get rid of. How do we get rid of something to the second power? We know about inverses. The opposite of addition, subtraction, opposite of multiplication is division. So what's the opposite? How do I undo taking something to the second power? Right? Well, what we're going to do here is we are going to go ahead and take the square root of both sides. The square root here and the power of 2 are going to cancel each other out. And then what is the square root of 625? I'm going to need to take out my calculator for this one. So again, if you're on your phone, if you're on Android, I believe you can type hit that square root key and type it out exactly the way you see it, square root of 625. If you're on an iPhone, you're going to have to tilt that thing on its side. You're going to have to hit first 625, and you're going to have to hit that square root key. If I'm looking at an iPhone right now, if you go all the way to the top left corner, you go down 1, 2, 3 rows, and then over 1 to the right. So third row, second column, I hit the square root key there. The square root of 625 is 25. 25 is equal to C. And again, at this point, what is that saying? Well, that is our missing side. This C right here, whoops, this is equal to 25. 25 what? 25 feet. The distance here measures 25 feet. So there we have it. That's how we use the Pythagorean theorem to find a missing side. All right, guys. Take a minute. What I want you guys to do is I want you guys to pause the video here. Try one of these 2 problems. Pick your favorite. When you're ready for the solutions, go ahead and hit play. All right, so what I want to hit, I kind of stopped. I didn't want to finish the entire thing because I want to show you this is a little bit different. On the previous example, I forgot to mention, we were finding the hypotenuse, the longest side. So you're typically finding C here. In these cases, you're actually finding one of the smaller legs, right? They give us the hypotenuse. So let me actually talk about the picture. So if you take a look at the triangle here, there was my 90 degrees. I went ahead and I went directly across, and I found that, hey, 7.1 feet, that's my C, that is my hypotenuse. And then again, X here, I just labeled that as my A, and 6.2 feet was my B. So I went ahead and I plugged it in. You can see that there in yellow. So for A, I plugged in my X. For B, I plugged in 6.2 to the second power. And then for C, I plugged in 7.1. And then I went ahead and I actually multiplied what I knew. I did 6.2 to the second power. It gave me 38.4. And I did the same thing over here with the 7.1. 7.1 times 7.1 gave me 50.41. Now, I can't really do anything with the x squared right now. At this point, it does become a little bit kind of weird, maybe not what we're so much used to. So what you actually have to do is you want to get x squared by itself, which means you have to get rid of that 38.44. And we do that by subtracting it from both sides. So make sure you guys have a calculator out handy. If we subtract 38.44 from both sides, those cancel. you're left with x squared is equal to, let me get a calculator. Let's see. What is 50.41 minus 38.44? That's going to go ahead and give me 11.97. All right, I got one more thing. Remember, we're still not done. We got to get rid of that exponent, power of 2. So we take the square root of both sides. The square root and the power of 2 cancel. We get x is equal to, what is the square root of 11.97? If I can unlock this phone. Come on, calculator. Let's go. All right, so now if we take the square root of this, I ended up with 3.45, and this number goes on for a while. 3.459. And it goes on for a while. It's okay, guys, for today. If you guys round to the nearest tenths or 100, I'm not going to be super picky about it. Here, I'll round to the nearest hundredths. So the second spot here, if I take a look to the right, that's a 9. It's 5 or more, so we're going to let it soar. X equals 3.46. All right, so that missing A over here measures 3.46 feet. That is our answer there. I'm going to quickly do, so you guys take a look at my work for the second one here. I'm quickly going to go ahead. I went through and I plugged in. I multiplied everything. I did the square of everything. Now I'm going to do the same thing here. I'm going to subtract that 114.49 from both sides. All right, so that gives me x squared is equal to, what is 256 minus the 114.49. That gave me 141.51. Now we're going to go ahead and take the square root of that. We're going to go ahead and get x is equal to 11.895. And again, if we round it to the nearest hundredth again, let's see if I can change colors here. That looks like it's going to be x equals 11 point. And again, if it's a 5 or more, we're going to let it soar. So that 9 would turn into a 10, which turns the 8 into a 9. It's going to give us 11.90. This missing side here measures 11.90 centimeters. There we have it. All right, moving on here. All right, example number 3. It says, look at each set of side lengths. Is a triangle with a given side length a right triangle? So here's the way that we're going to prove it. We're going to use our good old-fashioned Pythagorean theorem. A squared plus b squared equals c squared. We're going to plug in what we know, and at the end of it, I want a true statement. I want something like 4 equals 4. 4 does equal 4. That's a true statement. You'll see what I mean by that in a second. Now, one thing that I do want to mention is, don't forget, I cannot stress this enough, you have a right triangle. There's that perfect corner. If we go directly across from that, that is your hypotenuse. Okay, that should always be which letter? Remember, the hypotenuse should always be that letter C. And again, it's because it is the longest side. So be careful, be careful. Identify that one first. Even in this, where I don't give you a picture, take a look at these. Which of those values is going to be C? Which of those has to be your hypotenuse? I have 2.8, 4.5, and 5.3. This has to be my letter C. That is the longest side. I don't care what you call 2.8 or 4.5. We're just going to go ahead and call that one. We'll do it backwards. We'll call that one B, and then we'll call this one A. So you don't get in the habit of just doing A, B, and C. So let me provide myself a little bit of working space here. If I plug in all those things into my Pythagorean theorem, a squared plus b squared equals c squared, I get 4.5 squared plus b squared, which is 2.8 squared, is equal to c squared, which is 5.3 squared. All right, let's go through and multiply all this out. Let's see. Take me 4.5 times 4.5. I really should just do squares. That gives me 20.25 plus, all right, so I did that section there. Let's do the 2.8 times 2.8. 2.8 times 2.8. Careful, I almost did plus. We get 7.84. And this is equal to, what's 5.3 squared? 5.3 times 5.3. That gives me 28.09. And again, you're not finding anything. You're trying to make a true statement, trying to prove that these are actually right sides of a right triangle. If I take these two values here, and there's a plus between them, so if I actually go ahead and add them, what is 20.25 plus 7.84? That gives me 28.09 is equal to, if I bring down the other side, 28.09. Would you look at that? 28.09 equals 28.09. Is that a true statement? Yes, that is a true statement. So can these actually be the side lengths of a right triangle? 2.8, 4.5, and 5.3. We're going to go ahead and say yes. Yes, it can. And we proved it by using our Pythagorean theorem here to create a true statement. All right, so go ahead, guys, and try that with B and C. Take a minute. When you're ready, go ahead and hit play, and we'll go through the solutions. Don't forget, always identify that hypotenuse first. The C is the longest side, so make sure you identify that before you just start plugging in. Be careful. All right, guys, so there you have it, the solutions for the last two. So the second one, it was going to be a no. Now be careful, right? At the very beginning, I told you guys C is important. C is the most important one. That is your hypotenuse. That's the longest side. So here, if you did not use 32 for your C, that messed up your entire problem from the get-go. So be careful with that. For the last one, very same thing. 35 was the longest side here, so that's why I used it as C. And again, 21 and 28, I could have used them backwards, A and B. It doesn't really matter. But for the second one, I got a false statement. Take a look at that. 514 does not equal 1,024. And then over here, 1,225 equals 1,225, which is a true statement. So that's why we say yes. Those can be the side lengths of a right triangle. All right, guys. Example 4 here. We have problems where we have to do a little bit of cross multiplying. This is probably maybe you did back in middle school, back in algebra 1. So let's go through. Whoops. Let's go through that first example. So whenever you have two fractions like this, guys, they're set equal to each other, we have something that it's called cross multiplying. You're basically multiplying diagonally. And it doesn't matter which way you start first, just make sure you're multiplying diagonally. So what I'm going to do here is I'm going to multiply in this direction first. 3 times 8. Well, 3 times 8 is 24. Bring down your equal sign, and we're going to multiply now the other way. What are 2x's times 6? Well, 2 times 6 is 12. So that's going to give us 12x. And that's really, really nice because it gets rid of those fractions almost instantly, as you saw right there. And now it's kind of what we're used to. 24 equals 12x. If we divide both sides here by 12, 24 divided by 12 is 2. 2 is equal to x. All right, so that's the way we work it when we have two fractions that equal to each other. It just makes the life a little bit easier. These are little shortcuts that we can take. Now, they can kind of get a little bit more complicated. Take a look at the next one here. But we're still going to multiply diagonally. It's called cross multiplying. So I'm going to multiply here first in this direction. Now, careful, because I have a 4, and then up above there, I have a 5x minus 1. So it's like you're using distributive property. You're actually going to multiply the 4 times the 5x, and you're also going to multiply the 4 times the negative 1. Now, if you want to show that you can, right, basically this is what's happening. 4 times 5x minus 1. So I'll go ahead and do that. 4 times 5x is 20x. And then don't forget to do this for the second part. We did 4 times 5x. What's 4 times negative 1? That gives us negative 4. And we're done multiplying diagonally in that direction. So I bring down my equal sign, and I'm going to multiply one more time in the other diagonal direction. Now take a look at this one. 2 times, and then you have a 3 and a minus 2x. So you're going to have to, again, distribute. Think of this as the 2 out in front, and you're multiplying it by a 3 and a negative 2x in parentheses. Again, think of it as using distributive property. What's 2 times 3? Well, 2 times 3 is 6, right? What we're doing here is that first multiplication piece. And then we do it again. What's 2 times negative 2x? Careful. 2 times negative 2 is negative 4, negative 4x. All right, if we go ahead and we bring a little line down, we're going to combine our like terms here. Let me get rid of a minus 4x by adding 4x's to both sides. Just an algebra 1 problem. 20x plus 4x is 24x. Bring down my minus 4. That is equal to 6. I got 2 more steps here that we need to take care of. We're going to add 4 to both sides, just what we've been used to. Those 4's will cancel. You get 24x is equal to 10. And then we're going to go ahead and divide both sides by 24. Now, you can't divide 10 by 24 nicely. We're going to go ahead and leave it as a fraction, 10 over 24. I would appreciate it if you guys could simplify, right? It looks like I can divide top and bottom by, let's just start off with 2. This would turn into x equals 10 divided by 2 is 5. 24 divided by 2 is 12. I would appreciate it if you guys can simplify it whenever possible. All right, take a minute, guys. Please try the last 2. Go for it, go for it, go for it. When you're ready for the solutions, go ahead and hit. All right, guys, so here are your solutions. I want to go ahead and multiply everything, right? Cross multiplied. See if I can find a color that pops here. So I did 3 times 9x first, and then I did 2 times the 8, and then also times that negative 4. And then after that, it was just an algebra 1 problem. You guys can go ahead and check the work there. For the second one over here, I first went ahead and I multiplied this direction. I did 3 times 5x, which gave me 15. And then don't forget 3 times negative 8, which gave me negative 24. Then I bring down my equal sign and I multiply in this direction. 10 times 12 was 120. 10 times negative 2x was negative 20x. And again, at this point, it just becomes an algebra 1 problem, which you guys have been used to. All right, guys, there you have it. That's your review. These are the skills we're going to need moving forward. My cats are fighting. Perfect timing. I got to stop that. So here is your class activity, guys. You have 6 problems. Ooh, heads up on the last one, guys. It's 2x minus 8 all over 1. That's my hint for you guys. Go ahead and cross multiply and work that out, guys. All right, have a great day, guys. Oh, before you turn it in, make sure you guys check your answers with my sub. They should have the answer key. All right, I think that's it. I got to go break up that cat fight. Take care, guys. Have a wonderful day.